All right, welcome everyone to our first session of the day, Managing Digital Risk with Artificial Intelligence in a Post-COVID-19 World. We'll be hearing from Dr. Zulfikar Ramzan, who is a CTO of RSA Security. Welcome, Zulfikar, and thank you for joining us.
Well, thank you, Arena. Thank you to all the organizers. It's truly a pleasure and honor to be presenting today at the MIT AI conference for the Club of Northern California. And what I want to talk about today is the idea that when you think about it for a moment, COVID-19 has been arguably the greatest accelerant of digital transformation in recent times. In many cases, our physical experiences have been supplanted by digital ones. This conference, by the way, is one particular example of that. And as individuals and as organizations start to embrace digital technologies and embrace digital transformation in mass, their digital risk tends to increase. Now, I believe artificial intelligence can play a prominent role in how people can manage that digital risk. And today I want to talk about a few examples of where that can happen. But first, let's take a step back and think about what the office of the future is going to look like. What's our world going to be resembling as we look at the future? So as you can imagine, there are a lot of people out there who are eager to get back to a physical office. Some may want to get back for social reasons. Others may want to get back because they don't have a good place to work when they're at home, and so on and so forth. But the office of the future is probably not going to be that exciting in terms of where to be. They'll have social distancing norms to maintain. People have to wear PPE. In all likelihood, they'll reduce snacks and coffee and all the other kinds of perks you might typically get in an office setting. And so my expectation is that even if people are able to go back to some type of office environment, that environment will look very different and probably not be as desirable. And as a consequence, we'll see a lot more people who are going to be eager to work from home and continue to be remote. And that creates a set of challenges for organizations. So first and foremost, the reality is when you have people who are a combination of both remote employees as well as on-premises employees, there's a good chance that you increase your complexity in your environment. You have to manage additional infrastructure, manage additional applications, etc. Now, complexity and risk go hand in hand. When you have more complex systems, they have a greater likelihood of failure in one way, shape, or form, and those failures can be more catastrophic. Secondly, we'll see that many people are coming back into the office setting, bringing devices that have been at home for a long time, devices that may be out of the purview or be unmanaged from a security perspective. And there's a good chance they'll bring devices back onto the corporate network that have been compromised or be laced with malicious software and have all sorts of other issues that can wreak havoc on organizational environments. Third, the reality is that COVID-19 has created tremendous uncertainty. It's created tremendous stress for people. All that mental and psychological pressure will lead people to make mistakes. They'll make poor decisions as they get back to work in different settings. And security breaches often are rooted in some form of human error. Now, I'm not saying that's the only cause of a security breach, but if you look at all the major breaches, at some point there was some significant human error which enabled that breach to take place. On top of that, your security teams are also going to be fairly stressed out. Many of them will be working remote and will have a harder time making rapid decisions. And so an organization's ability to respond effectively to the latest wave of threats and issues is certainly going to be impacted dramatically. Now, if all that's not bad enough, what I'm seeing when I talk to our customers, and all of these items, by the way, do come from customer conversations, is that in many cases, our customers are expecting that their budgets will either be flat or declining in the forthcoming year. So on the one hand, you have this increasing set of challenges, but on the other hand, you've got this decreasing or potentially flat budget. And how you reconcile the two is going to be a major issue as organizations grapple with environmental considerations and also grapple with being able to effectively operate in a post-COVID-19 world. Now, I believe AI has an important role to play in this context. And if you look at the history of AI and cybersecurity, they do go hand in hand. As many of you may know, MIT was the birthplace of RSA security. Here's a picture taken at MIT of Ron Rivest, who's the R in RSA in the middle. On the left-hand side of the slide, you'll see Adi Shamir and his hipster beard and his cool, trendy t-shirts, who's the S in RSA. And on the right-hand side of the slide, you'll see Len Edelman, who is the A in RSA. These three co-founded the RSA, or co-developed the RSA algorithm and helped co-found RSA security. Now, what's really remarkable, many of you may not know this, but in addition to teaching 6.875, which is computer network security at MIT, Ron Rivest also taught 6.876, which was machine learning. He had interests in both areas. And it turns out that cryptography, which is the main focus of the research of RSNA, is inextricably tied mathematically to machine learning. Think about it for a moment. Machine learning is about asking a really basic question. I have this black box. I get to see what goes into the black box. I get to see what comes out of the black box. And now the goal of machine learning is to figure out what's going on inside that black box. Can I come up with a model that explains the behavior of that black box with respect to the data that goes in and goes out? Cryptography asks almost the exact opposite question. It says, can you build me a black box so that if anybody even sees what goes in and what goes out, they'll have a hard time gleaning any reasonable information about how that black box actually operates. And so in many ways, there are two sides of the same mathematical coin. And so it should come as no surprise that cryptography and machine learning have co-developed in some interesting ways, and more broadly, that there have been many applications of AI in the field of cybersecurity. I want to highlight a few historical cases that have come up over the past couple of decades. So first of all, if any of you use an email program of any sort, there's a good chance that email program has some type of anti-spam capability. That anti-spam capability likely uses machine learning techniques to be able to identify whether or not a given email message is legitimate or whether it's spam. If any of you engage in online shopping or use any form of online transaction service, there's a good chance that on the back end of that service, the fraud detection algorithms employ machine learning techniques. And we've seen this at credit card companies, at banks, at e-commerce vendors, et cetera. And they use those techniques to identify whether a given transaction is fraudulent or legitimate. Antivirus software has been using machine learning techniques now for approximately 2 decades plus in production environments to identify whether or not a file on your system is legitimate or malicious. And it's a good way to identify malware and other types of computer viruses. And then finally, in network security, we've seen a lot of applications of machine learning. And there are, again, production instances where machine learning techniques have been applied to look at network traffic and identify if that traffic is legitimate or malicious based on its characteristics. And again, these are just historical examples, and many of these examples have been around now for decades in production environments, successfully employing machine learning to help manage digital risk. But as we think about COVID-19, a new set of challenges are going to come up. And I want to talk about a few new areas where we can apply machine learning and AI techniques to resolve what I think of as emerging challenges in the post-COVID-19 context. And I want to talk about 3 specific areas that I think are salient and where I can quickly give you an overview of the opportunity. So first and foremost, I want to talk about the area of governance, risk, and compliance, and talk about how one can do regulatory content analysis using machine learning techniques, specifically in the area of natural language processing. Second, I want to talk about vulnerability management and remediation, and specifically how one can do vulnerability prediction using supervised machine learning techniques. And then finally, I want to talk about digital risk quantification, and specifically how one can do multidimensional asset importance analysis using techniques from machine learning, and specifically in the area of both unsupervised learning and clustering, supervised learning, as well as graphical models. So with that, let me talk about some of these key areas really briefly, and then leave some time for some Q&A at the end. So the first area I want to talk about is in the area of regulatory content analysis. Now here's the situation you're trying to deal with. Organizations today need to be able to comply with a rapidly growing number of regulations. So for example, imagine a heavily regulated industry, financial services, healthcare, et cetera. New regulations are coming in, and right now, given the current climate, they're coming in at a very rapid pace. There may be new regulations around employee privacy that will come up in a post-COVID-19 context, regulations around how offices should operate and behave, and what they may or may not be allowed to do in these new settings. Now, a lot of people think that they'll be able to get away with a reprieve, that maybe there'll be less scrutiny around regulatory requirements, but I think that's a false notion, because when you think about it for a moment, if anything, we've become more digital in the last few months. And that means we've leave this set of digital breadcrumbs wherever we go, which means our privacy is on the line at every single moment in every interaction we have. And therefore, it becomes more incumbent on organizations to do a good job of protecting consumer data, protect employee data, of protecting customer data. And the regulatory landscape is bearing this out. We're not seeing too much of a reprieve when it comes to relief around regulatory compliance requirements. If anything, everyone's basically saying you have to still adhere. Maybe we'll give you a few extra months here or there, but for the most part, if you're not already thinking about these issues, you're far behind. Now, when you couple that with the fact that information about these requirements has to be taken by an organization and then mapped against existing controls, that problem becomes quite complex. The reason for that is that today's regulations are typically communicated and updated through a variety of authoritative sources. Many of those sources may be local. So for example, you may have some new regulation that impacts your industry in a specific jurisdiction, and information about that new regulation may be in the minutes of some council meeting that you've got to now go find, interpret, and then manually map back to your controls. And today that process is very much manual. It takes hundreds of hours for organizations to map all this content to their controls. And again, this problem becomes a lot worse in a post-COVID-19 context. Now we can apply machine learning techniques to address this problem. Specifically, we can apply natural language processing to analyze regulatory content. And by doing that, we'll be able to find ways of automatically suggesting which controls might be the most relevant for a given piece of regulation just by comparing the text of the control with the text of the regulation. And then furthermore, given a piece of regulation, we may be able to pull other examples of similar regulations to which the company has had to adhere in the past and provide the analyst who's sitting there typically making these mappings and figuring out what goes where, the ability to take a more cohesive approach that enables an organization to understand their regulatory compliance posture at a large scale versus getting caught up in the minutia of hundreds of thousands of maybe, potentially tens of thousands of different regulatory documents that they've got to now look at. So I think this is an area that, again, is ripe for machine learning and AI techniques, and we're seeing a lot of opportunity in this particular area. I want to talk about a second area, which is in the area of vulnerability protection. Now, this comes up a lot in cybersecurity contexts. The way that most organizations work is they typically will scan their existing systems on a routine basis for known vulnerabilities, known weaknesses. And the hope is that if you can identify a known weakness in a system or an application, you can go ahead and patch that system, patch that application, help remediate the weakness, and in turn, take away some low-hanging fruit for threat actors. Now, this sounds pretty basic, but again, if you look at all the major breaches that have occurred, a large number of them end up involving, at some point, some basic vulnerability that had gone unpatched. It was really simple process that's got to be implemented correctly. And it turns out to be a simple process that most people don't get right for a lot of reasons. One complication with that process is that because scanning systems can be expensive, it turns out that most organizations will only scan systems periodically. So typically maybe every 4 days, they'll run a whole scan of the organization to identify issues. And that means that certain systems end up getting missed in the scan. So for example, if a system is offline, it's not on the internet, if somebody's remote, then that system may not be part of that scan, and any vulnerabilities or weaknesses on that system will not be caught. Now, when you couple that with what's going on with COVID-19, with employees being remote at much larger scales, that means that many more systems will be remote when the scan takes place, which means the likelihood of capturing a vulnerability or an issue during the course of a system scan goes down considerably. That means that as an organization, your overall exposure will go up considerably. The way we can resolve that problem, again, is using AI techniques. And specifically, we can start off by taking the existing scan results to identify known vulnerabilities. And then we can apply techniques from clustering. So we can basically categorize all of our existing assets based on configuration information. So for example, operating system information. And then we can figure out whether or not that information seems to be likely in the context of somebody having a vulnerability. So imagine you've got system A, and system A is known to be vulnerable. You figured that out during a scan. It's got vulnerability of a certain form. And now we see system B, and we know system B is in our environment. And we know system B's configuration is very similar to system A. Maybe system B's got the same operating system, some of the same applications, etc. We can now infer, and this is using a technique known as clustering in machine learning, that system B is likely to also be vulnerable to the same issue as system A, even though we didn't get a chance to explicitly scan system B for that information. And specifically within clustering, there's a technique known as nearest neighbors that you can apply to identify unscanned assets that are likely to have a vulnerability. And we've seen this technique, again, provide very high levels of accuracy in terms of predicting vulnerabilities, number one. And number two, it can reduce the exposure window of that system by over 100 days. And that's a pretty significant amount. Imagine for a moment that you have a system in your environment that for several months on end has gone unpatched. That is some serious low-hanging fruit for an attacker. We can help eliminate that low-hanging fruit. And the final application I want to talk about is in multidimensional asset importance analysis. So today, as I mentioned, organizations have a rapidly increasing number of digital assets. Everyone is going more digital, they're embracing new technologies, they're using new applications. And it's hard to know when you have that many new assets coming in at a global scale, which assets are really critical to your business, which have a massive business impact versus which ones are maybe less important. So for example, you have a server somewhere. Is that server a production server that's got to be protected? Or is the only thing of value on that server the PDF of the lunch menu for the cafeteria? I guess in the future, there may not be a cafeteria, so that's going to be an irrelevant example. But for the most part, people don't often characterize which case it is. Is it a critical asset or not? And that prioritization is going to be really crucial in a post-COVID-19 context where, as I've mentioned, the complexity of the environment's gone up, but the budgets have gone down. And therefore, organizations can't afford to peanut butter all their resources around a large number of assets. They've got to make sure that they spend their security budget on what matters most and they spend it intelligently. Now, to make matters more complicated, the way that organizations typically solve this problem is through what's called a configuration management database, or a CMDB, which effectively amounts to a manual list of assets that's been curated by some individual to identify what's important and what's not. Now, in most organizations, a CMDB is an Excel spreadsheet that was probably created 3 years ago, horribly out of date, totally not a scalable solution, and manual efforts we know inevitably will fail at some point. Now, again, AI and machine learning can play an important role in helping us to identify critical assets. So we can start off, for example, by looking at your overall network traffic, what systems are running on your network, and analyze the behavior of those systems. We can then combine that with any existing CMDB data to identify additional assets that should be categorized as important but may not have been. So kind of like I talked about in the previous slide, imagine you've got asset A, and asset A is known to be important, it's on your CMDB, you've classified it as a critical production server. And now you see asset B in your environment based on it being on the network. And for all intents and purposes, asset B looks like it behaves very similar to asset A. It exhibits the same kinds of network traffic. It's got some of the same configuration parameters. It's got some of the same behaviors, etc. You can then infer that asset B in all likelihood is also critical, but simply was not included on your CMDB because nobody got around to it. And again, the idea here is to use techniques around clustering and nearest neighbors and similar approaches. But in addition, you can also apply graphical models to this problem. And graphical models can look at the topological structure of different assets in your network. So for example, if asset A is connected to asset B, that says something about the risk of one versus the other. In many cases, especially in cybersecurity, a threat actor may compromise one asset and use it as a beachhead to compromise additional assets later on. We can then identify those beachheads and identify situations where maybe an asset on its own was not considered critical, but because it's connected to a critical asset, that initial asset should be protected in much greater detail. And so again, machine learning and AI plays an important role in this area as well. So I've highlighted 3 areas where machine learning and AI can play a prominent role in the context of helping organizations manage digital risk in a post-COVID-19 era. I want to offer a few key takeaways in closing. So number one, we've talked about the idea that there's been this acceleration of digital transformation, and that's led to a disproportionate acceleration or increase in digital risk. Fortunately, AI can help play a major role in addressing some of this digital risk, and AI and cybersecurity have gone hand in hand. They've co-developed in many ways, and we've seen many historical examples where AI techniques have been used to address cybersecurity issues and help organizations manage digital risk. And finally, I think there's some new opportunities in this area, specifically in topics like regulatory content analysis or vulnerability scanning, or simply in understanding the importance of all your assets. And these are areas that typically have not been looked at under an AI lens for cybersecurity, but I think the opportunity is ripe for us to do so. And if anything, the stakes have never been higher. Every single one of us has leveraged digital more and more in the last few months. Can you imagine for a moment what your life would be like if we didn't have digital capabilities? How much of a disruption COVID would be? Now, it's still a disruption, but for the most part, we've been able to manage that disruption using digital technologies. But for digital technologies to be successful, people have to trust those technologies. We have to find ways of engendering trustworthiness into the digital realm. And that can best happen and most effectively happen if we find new ways to manage the risk associated with digital transformation. So I think there's a powerful opportunity here for all of us to think about where we can use AI techniques to manage digital risk. So with that, I want to thank you for your time and really, again, thank the organizers for giving me the opportunity to present here today at the MIT Club of Northern California AI Symposium.
Zulfikar, thank you so much for your presentation. So we've got a few minutes for questions, and it looks like there are a few on Slido.
Okay, perfect. I'm going to just switch over and see the questions.
Sure.
All right, so great, they're coming in. So first is, I guess I'm going to go top down here. So Karen asked, what aspects of RSA's work have seen the biggest surge in demand since March due to COVID-19? It's a great question. Probably the biggest area that we've seen, and we saw a massive surge in this area, is one of RSA's core capabilities is around enabling people to work remotely. So we have a whole suite of authentication technologies that allow people to work from a remote location and access critical resources in their organization. And that was an area that we saw a major surge in, because all of a sudden you had organizations that said, they call us on a Friday afternoon and say, hey, by Monday we have to enable 3,000 more people to work remotely. So that was one area we saw a lot of business. The second area we saw a lot of a rise in business was in the area of online fraud. So we have a whole online fraud offering. As you can imagine, when people do more shopping online, when they engage in more e-commerce transactions, the fraudsters start to look there. I'll give you one data point. One of our customers, and it's a major grocery chain, they saw an 800% increase, so 8-fold increase in the number of fraud attempts at their grocery chain in the wake of COVID-19. And again, it shouldn't surprise people. Or people are buying more groceries in general, therefore threat actors are going to focus on those areas. In addition to those areas, we've also seen a lot of emphasis on managing digital risk. That was my focus today. But certainly in areas like third-party vendor risk and the risk of business continuity and all the associated elements, thinking about your supply chain. So that's been a third area. And then finally, people have been thinking about what their security operations center looks like in a post-COVID-19 world. That was typically something that was done in an on-premises fashion. So you would have a war room and people would get together and discuss incidents and figure out how to triage them and manage them. That's all changed now, and it's gone to a world where we're no longer doing that, but we have to do a much more robust job of making those decisions remotely and in a distributed fashion. So second question from Anonymous is, what aspects of machine learning are most important to study for a career in security? You mentioned graphical models and NLP, how to prioritize it. That's a wonderful question. I would say that for me, I think it's a combination of two things. One, I don't know that you need to specialize in one particular aspect of machine learning. I think if you understand, some of the key elements and the key models and key approaches, so understand your basic supervised learning techniques, random forests and so on and so forth, understand some basic unsupervised learning like clustering, et cetera, and know how some of those techniques can be applied in other domains like natural language processing. I think if you have a good overview, that's going to be important. What actually I think is more important is understanding the domain, because you can take the best machine learning techniques, but without good domain understanding, you're not going to be able to use those techniques effectively. And so I think the key opportunity here is at the nexus of knowing the techniques well enough to know how to apply them correctly, but more importantly, understanding the domain itself to know what questions to ask of your data as you apply machine learning techniques. And that gives me the final point, which is that really it's about data at the onset. Everyone gets caught up in the latest techniques saying, hey, I want to build this big neural network and do all these complicated mathematical transformations, et cetera. What's actually more important is starting off with good data, then having good context and understanding the business case so you know what insights to look for in that data. And then and only then does it matter what machine learning algorithm you pick. And it turns out that if you do it in that order, you'll be very successful in applying machine learning in production environments. If you reverse the order and focus on the algorithm first, then there's a good chance that you'll have this fancy algorithm, but it won't actually provide business value. And I've seen this over and over again. To really understand the data itself, think about data cleanliness, understand the domain, and then understand the algorithm at the end.
So Zulfikar, we have about 2 minutes left. I thought we could take one last question. This one's from David. Will the use of AI to mitigate risk be affordable enough to protect soft targets like public schools and nonprofits? What are your thoughts on that?
Yeah, so I think, one thing we're trying to focus on, and I think AI has become much more accessible to the masses in the sense of, one thing we're very focused on right now is, can we take a lot of the data that you're looking at, send that data to maybe a cloud service, and then analyze it in the cloud, and therefore reduce the on-premises footprint associated with those environments, and therefore reduce the cost as well. We've seen a lot of success in that environment. A lot of the technology I talked about, like authentication and some really basic elements, can play a really critical role, and we've seen them work successfully even in small organizations. So I think we've seen one thing over the last 5 years, which is AI techniques have really been pushed out to the masses. I mean, every antivirus software, every anti-spam filter, all these things have been using AI for a long time, and all are very accessible to even small environments. I think it's a major question that we have to ponder, over the next few months. And I don't know that we're going to resolve it satisfactorily on all levels. There's certainly a physical dimension of opening up schools again, as well as a digital dimension. But what I do know is that we still will have a strong component of distance learning going into the future, even if we're able to reopen schools. And I think AI plays a strong role in helping to protect those distance learning environments and help protect the integrity of the educational process.
Absolutely. Well, thank you. It looks like we are right on 11:25 on the dot. Sorry, 8:25 on the dot. Zulfikar, thank you so much for your time and your fascinating presentation. Really appreciate it. And for our viewers, please stick around, and our next session will begin in 5 minutes at 8:30. All right. Take care, everyone.
Thank you.
Thank you.